Today we're going to review the key concepts from Chapter 8, the chapter that was all about trigonometry. Starting with the Pythagorean theorem. The Pythagorean theorem, that was a squared plus b squared equals c squared. Go ahead and fill that in. You use Pythagorean theorem to solve for a missing side in a right triangle if you already know 2 out of the 3 sides. So look at the example below. We have numbers for the lengths of 2 out of the 3 sides. We're only missing one side, so it's a perfect case for using Pythagorean theorem. Keep in mind that C is always the hypotenuse, the longest side. You can also identify C as the side that's always opposite the right angle, in case it's hard to tell which side is actually the longest. The hypotenuse is always across from the right angle. It's like the right angle points to the hypotenuse. Doesn't really matter which leg side is A or B. You'll have either 10 squared plus x squared equals 16 squared, or if you swap to the A and B, x squared plus 10 squared equals 16 squared, but C has to be the 16. You can go ahead and simplify that. After you finish the squaring, you can get x squared by itself by subtracting 100 from both sides. Now, to get just x without the square, you have to do the opposite of squaring, square rooting. But I want you to notice that when you check to see if the square root of 156 is a whole number in your calculator, it's a run-on decimal. So you're going to have to simplify the square root instead. Remember doing that factor tree? There's a couple different ways to break down 156, but try dividing by 4. Remember, if your factor tree has pairs of the same number, that's the number that goes outside the square root. Numbers that aren't doubles are stuck inside the square root. So your final answer, the simplified square root, is x equals 2 square root of 39. So that's using Pythagorean theorem. There's a couple related theorems, for example, the converse of Pythagorean theorem, that uses the same concept, but to identify what type of triangle you have instead. So here's the related rules. Go ahead and copy them down. If you have 3 sides of your triangle that you know and you're trying to figure out what type of triangle it is, you're trying to classify it, see what the relationship is between c squared and a squared plus b squared. If it's equal, and Pythagorean theorem works perfectly and creates a true equation, that means it's a right triangle. But if c squared is less than the combination of a squared plus b squared's answer, then it's acute. And if c squared is greater than the combination of a squared plus b squared, then it's an obtuse triangle. So to classify a triangle into one of these 3 categories, you first need to identify the C, which would be the biggest side. And then you could plug in 7 where C is, and 3 and 5 for A and B. I usually just leave a blank or an empty circle since I don't know whether it's going to be equal, less than, or greater than sign yet. You could simplify that. 7 squared is 49, and then 3 squared plus 5 squared is 34. Oh, 49 is greater than 34. So that tells us we would fill the circle in with a greater than sign. Greater than sign. If c squared is greater, then it's obtuse. It is an obtuse triangle. You are done classifying it. Then there are the special right triangles. There's really 2 special right triangles. Go ahead and copy this picture in the 45, 45, 90 box. That's your first special right triangle. Anytime you have a 45, 45, 90 degree triangle, it's going to be a type of isosceles triangle. Because if you have 2 matching angles, then you have 2 matching sides. That's why they both have L as their symbol. They have to be the same size. If you know this L equals, say, 10, then so does the other L. It's going to be isosceles. The only side that will be a different length is the hypotenuse side, the longest side. But the cool pattern is it's going to be the same number as L was, but with a radical 2 after it. So using this pattern to solve problems like this and find the missing sides, I would first identify the hypotenuse and write L radical 2 on it. And then I would After that, I identify the two L sides. So if this L equals 6, then the other L side will also equal 6. So you could write 6 on this missing side. And then if I know L equals 6, I could plug that in for L here and say, oh, the last side would be 6 radical 2 units long. So those are your two answers. L equals 6 and L rad 2 equals 6 radical 2. Go ahead and copy the diagram for the 30, 60, 90 triangle. The pattern for 30, 60, 90 triangles is that the shortest side of the triangle is always L. The hypotenuse is always 2L, twice the shortest side, and the medium side is the short side, but with a radical 3 after it, L radical 3. So a good first step with these special right triangle problems is always to label the sides with L, L rad 3, and 2L. I usually find the short side first and label it L, and the hypotenuse, label it 2L, and then the medium side last, L rad 3. Now here, we're told that the L side is equal to 2 radical 2. So that means we get to plug 2 radical 3, I'm so sorry. We can plug 2 radical 3 in for L in the equations for the other two sides. So here, to solve for side x, we'd plug in 2 radical 3 in front of the radical 3 that's already there, where L used to be. Now we could multiply two numbers that are both in radicals together. Remember the shortcut, if you're multiplying twin square roots, the answer is the number without the square root. So that radical 3 times radical 3 really becomes just 3. The logic is radical 3 times 3 is radical 9, square root 9 becomes 3. Now it's a number that you can multiply by the 2 in front, since now neither of them have radicals. And your final answer is that x equals 6. Just for practice, we're also going to solve for the 2L side, even though the variable is not on that side. We could plug in 2 radical 3 for the L here. So it becomes, instead of 2 times L, 2 times 2 radical 3. Normal numbers can go ahead and multiply. Your final answer is that the hypotenuse is 4 radical 3 units long. Now, here we have a problem where we cannot use Pythagorean theorem to solve for the x side because we only know one out of our three sides. And with Pythagorean theorem, it's kind of hard to solve for, say, an a side when you know only c but not b. Because of that, you are going to switch methods. You're going to use SOHCAHTOA instead. Go ahead and write SOHCAHTOA in that top box. So remember with SOHCAHTOA, or trig ratio problems, you first identify what your starting angle is. That's the angle that you have information about. That's not the right angle. Here we know the 33-degree angle. That's our starting angle. Based on where that starting angle is, we could label our opposite side. It's opposite of the starting angle. It's across from it. So O for opposite. The hypotenuse side, write an H on that. And adjacent means next to. It's next to the starting angle without being the hypotenuse. Notice how for this picture, we know O and H sides, but there's nothing written at all on the A side, so we can't really use the A side. So if we have information about the O and H sides, we will look at SOHCAHTOA. Oh, the only one that has O and H in it is SO. We have a SO problem. S stands for sine, so sine of our starting angle, 33, equals O over H, which becomes x over 14. You type sine of 33 in your calculator. You could round to the hundredths place or the thousandths place. Up to you. And then you get about 0.54 or 0.545, and then you can put that over 1 to make it a little bit more straightforward to cross multiply to solve. And you get x's around 7.6 units long. Notice how there's a difference between the diagram for this problem and the problem to the right of it. For the problem you just solved, x was on a side. For the problem to the right, x is inside of an angle. So to solve for missing angle length, you could still use SOHCAHTOA to set it up, but in the end, you're using the inverse of SOHCAHTOA, inverse trig functions, to solve. So quick recap of how that looks. You still say, well, this is my starting angle, so you label your H, O, and A. Remember, O is for opposite, it's across from your starting angle. H is the hypotenuse. The right angle always points to the hypotenuse, that's one way to identify it. And A for adjacent. This time, we have information about the A and H sides. And so SOHCAHTOA, that would be a CA problem if it has A and H. So now you could set up your trig ratio. C is for cosine, so cosine of your angle, which is x, so cosine of x equals A over H, which becomes 6.5 over 10. Now, our goal is to solve for x, in other words, to get x by itself. So we have to cancel out the cosine that contains the x. The only way to cancel out a cosine is to do the opposite, inverse cosine. However, whatever you do to one side of an equation, you have to do to the other. So you inverse cosine the fraction on the other side as well. So this is what your equation ends up looking like. X equals inverse cosine of 6.5 over 10. Remember, to type inverse cosine, you use either your second or your shift button and then hit cosine. And you should get x is around 49.5. Word problems using SOHCAHTOA. The two key vocabulary terms you need to remember for the word problems is angle of depression and angle of elevation. Anytime you have an angle that's looking up above a horizontal line, it's an angle of elevation. But anytime you have an angle that's looking down below a horizontal line, it's an angle of depression. Let's look at the example problem. An observer on a cliff 360 meters above sea level, so someone standing here. The angle of depression, or in other words, how far they have to tilt their head down to look at something, the angle of depression to the ship is 28 degrees. What is the horizontal distance between the ship and the base of the cliff? So we label the picture with the information we have. We know how tall the cliff was, 360 meters above sea level. We know how far they had to tilt their head down to look at the ship. That's 28 degrees angle of depression. And they're asking us what is the horizontal distance from the ship to the base of the cliff. So that's where the x goes. Now, I want you to notice right now the 28 degrees is not even inside the triangle that we're going to use to solve this problem. However, we know that if there's a 28 degrees here, the alternate interior angle to that will have to match and also be 28 degrees. And now that's a corner that's actually inside your triangle. So based on this 28 degrees, now you could label your H, O, and A sides and realize that this is a tangent problem, TOA. TOA, so it has to be O over A, opposite over adjacent, even though that means that this time the x is under the fraction bar. Watch out for that, because the O has to go on top of the A side. You type tan 28 in your calculator. Once you get that, I like to put that over 1 to make it visually easier to cross multiply. After you cross multiply, you get x by itself by dividing both sides by 0.532. And you should get something between 676 and 677 meters for the distance between the ship and the base of the cliff. That's it for today. Go ahead and work on the rest of the packet, and don't forget to Schoology message me if you have questions.